It's time to find all the extrema of this function, and to do that, we'll need the first derivative. Remember, we're looking for those critical points, or singular points. That's where the first derivative equals 0. Well, right off the bat, we have a product rule here. Think of the first function as e to the x, the second function as x squared minus 3. Product rule says we take the derivative of the first. The derivative of e to the x is e to the x. It's its own derivative. We multiply it by the second function. Just copy it. Product rule says plus in the middle. This time we copy the first function, copy e to the x, and multiply it by the derivative of the second function. X squared, using the power rule, its derivative would be 2x. The derivative of minus 3 is 0. That's the derivative of that first part. Again, plus 5, the derivative of a constant, is 0. There's our first derivative. It's often helpful, if you're finding critical points, to factor. That's because we're setting this entire equation equal to 0, and factored equations are much easier to solve. So I notice here that there's a greatest common factor of e to the x. That's a GCF. We can factor that out. We can pull an e to the x out from both terms. That would leave us with x squared minus 3 plus 2x, or you might prefer to see that as plus 2x minus 3. And if you see it that way, you might be tempted to factor this even further. Can you think of two numbers that multiply to get negative 3 and add to get positive 2? This now factors into x plus 3 times x minus 1. This is equal to 0, and so we have a product equaling 0. We'll just set each piece equal to 0. This will give us our critical values. So we have e to the x equals 0, x plus 3 equals 0, x minus 1 equals 0. This first equation, e to the x equals 0, e to the x is never 0. E to the x is always positive. We can just throw away that piece. X plus 3 equals 0 means x equals minus 3. We'll keep this. X minus 1 equals 0 means x equals 1. We'll keep this. These are going to be our critical points. So if we use the first derivative test here, we're looking for where our first derivative switches from positive to negative or negative to positive. That will tell us whether our critical values are maximums or minimums. A nice way to do this is to put these on a number line. Here's negative 3, and here's 1. So we've split our real number line into 3 intervals, and we'll plug in test points from those intervals into our derivative. The derivative will tell us whether our function is increasing or decreasing, whether our first derivative is positive or negative. So we need some test values here. I think something less than negative 3 would be negative 4. Something in between negative 3 and 1, 0 is always good. And something bigger than 1, I think I'll pick 2. So we'll substitute those 3 values into our first derivative. Now, I think it'll actually be easiest for us to substitute them into this factored form. You see, e to the x is always positive. Doesn't matter what we plug in. So that's not really going to affect our calculation. All we care about is positive or negative, and since e to the x is always positive, we won't worry about it. But if we plug in negative 4, well, that would be negative 4 plus 3 times negative 4 minus 1. Negative 4 plus 3 is negative. Negative 4 minus 1 is negative. We have a negative times a negative, that's positive. So our first derivative is positive when we're less than negative 3. That means our function is increasing on that interval. Let's try 0. Do the exact same thing. Again, we're ignoring e to the x, it's always positive. But if we plug in 0, we'll have 0 plus 3 times 0 minus 1. That would be 3 times minus 1 is negative. Our first derivative is negative, means our function is decreasing on the interval minus 3 to 1. Our function is going down. One more time, let's plug in this last test value of 2. Maybe you can guess what happens here. We have 2 plus 3, 2 times minus 1. That's a positive number times a positive number. That's positive, And when our first derivative is positive, our function is increasing. Okay, look at what's happening here. This picture tells all. Before -3, our function is going up, and after -3, our function is going down. That means the value of -3 is a maximum. When a function switches from increasing to decreasing, it has a top point there. -3 is a maximum. Before 1, our function is decreasing. After 1, our function is increasing. If our function is going down and then goes up, it's bottoming out at 1. 1 has to be a minimum. So we've classified these critical points. Let's plug them in and actually find the extrema. We concluded we have a max at -3 as an x value, and we have to plug in -3 to find the y value. We also have a minimum at 1, and we have to plug in 1 to find that y value. Our function was e to the x times x squared minus 3 plus 5. Let's just sub these in. If we plug in -3, this would be e to the -3 times -3 squared minus 3 plus 5. 3 squared is 9, minus 3 is 6. We'll just call this 6 e to the -3 plus 5. That's our y value, f of -3, which is a maximum of our function. Let's do the exact same thing to find our minimum. F of 1 is e to the first, 1 squared minus 3 plus 5. 1 squared is 1, minus 3 is -2. -2e plus 5, that's the y value for our minimum point, which was 1 minus 2e plus 5. Hey, those are our extrema, which we classified. I think there's a lot of good information in this video, so it might be worth watching a second time.